Hi Chintu, you look very worried. Sir, actually, I am not able to understand Newton's law of motion. Why? Sir, what was the reason that Newton gave these laws of motion? Okay, so let me help you on this. Now let us start with this experiment. In this, there is one cardboard, one coin, and one glass. I will hit the cardboard very hard. Now you see that when cardboard is hit, the coin does not move with the cardboard. Rather, it falls down in the glass. Why? Pause the video and think about it again. What should have happened is that the coin should have moved along with the cardboard, but it did not happen like that. You see, the coin directly falls into the glass. Why? Now let us start with another experiment. In this, a passenger is traveling in train and standing straight. Suddenly brakes are applied. What happens is the upper part of the body moves forward, but the lower part of the body does not move at all. Why? Pause the video and think again. Why is it so that when you are traveling in a car or in a train and when brakes are applied, your lower part of the body stands still, but upper part of the body is pushed forward? These are two experiments that you should think before studying Newton's first law of motion. Newton thought a lot about this. He said that I am applying force on the cardboard, so cardboard is moving, but I am not applying force on the coin, so coin is not moving. He then thought that coin was lying still, it was not moving initially. After the cardboard has moved, even then the coin is lying still, it is not moving. This means that this coin is lazy, it does not want to move, so it falls down. Newton said that this is happening because this coin has some mass. He used a new word for this. He said it has inertia. Because of this inertia or because of this mass, it stays there. Unless you apply a force on it, it will not move. It will remain there. And hence, since it has to remain there, it cannot move from there, it simply falls down. So that is how he explains this experiment. Now Newton developed a theory out of this experiment. He said that something which is in a state of rest remains at rest unless an external force is applied. What does this mean? In very simple words, it means if someone is lazy, he will remain lazy unless somebody pushes him. So in that experiment, the coin was lazy and the force was applied on that cardboard and not that coin. So the coin continued to be lazy, and when the cardboard was moved, coin simply fall down in the glass. That was what was happening. If you want coin to be moved, you have to apply force on the coin. It is as simple as that. Now let us see the second experiment that we have seen earlier. For the second experiment, you can see the theory that Newton developed. He said that something which is in motion continues to be in motion with uniform speed unless external force is applied. This means that if something is moving, it will continue to be moving unless you put a external force, you put a force on it and stop it. Now I'm sure it doesn't make sense to you, so we will see how this theory is applied in that second experiment. Now just see what is happening in this experiment. The passenger is traveling. There are two parts of this passenger. One is upper part and the other is lower part. Now according to Newton's second theory, he said that what is in motion remains to be in motion. That is, it will continue to be moving unless a force is applied. So let us see both the parts separately. The second part, the lower part of the body, it was in motion. Brakes are applied. When brakes are applied, an external force is applied on the lower part of the body. So what is happening is when those brakes are applied on the lower part of the body, immediately the body gets stopped. The lower part of the body gets stopped. But what happens to the upper part of the body? Pause the video and think again. When what is happening is that when the upper part of the body is moving and brakes are applied, that braking force is not applied on the lower part of the body, right? On upper part of the body. Since no force is applied on upper part of the body, the upper part of the body will continue to be moving. It will not stop. So when suddenly brakes are applied, it wants to remain in motion. So it goes forward. It goes forward because it wants to remain in motion, because no force is applied on that upper part of the body. I'm sure you must have got this. Yes, sir, I understood it. But tell me, why is it so that two parts of the body are being considered separately? Why not one? Why not entire body is being seen? This is because the two parts of the body are behaving differently. The lower part of the body is attached to the ground. When brakes are applied, there is a negative force. That braking force is applied on the ground of the surface of the vehicle. So the lower part of the body gets attached to that braking force and it immediately stops. But when upper part of the body is seen, it is not connected to the ground surface of the vehicle. It is connected to the upper hanging chain. The person is hanging with that chain. So what happens is that negative force is not applied on the upper part of the body, and it wants to remain in motion, so it just moves forward. So sir, what is Newton's first law finally? See, I will make it easy, very easy for you. जो जैसा है वो वैसा रहना चाहता है, और वो अपने आप को तभी चेंज करेगा जब कोई उस पर फोर्स डाले. अगर वो रेस्ट में मूव नहीं कर रहा है, बैठा हुआ है आराम से, तो वो आराम से ही बैठा रहेगा जब तक कि उसको ऊपर कोई फोर्स ना डाले. अगर वो मूव कर रहा है तो वो मूव ही करता रहेगा जब तक कि उस पे कोई फोर्स ना डाले. जब उस पे कोई फोर्स लगाएगा तभी वो रेस्ट पे आएगा. It is as simple as that. So something which is at rest will remain at rest unless an external force is applied. Something which is moving will continue to be moving with a constant speed unless an external force is applied. You have already seen two examples. I will show you a few more examples to explain this concept. Look at this third example. In this third example, there is a carpet, and in this carpet there are various dust particles. These dots are dust particles. You want to clean the carpet. How will you do that? Sir, I will pick each of the dust particles. That is how a common man thinks. But Newton was sharp. Newton said that I can apply my theory here. I can apply my first law of motion here. How, sir? Just think about it. There are two parts of this thing. One is carpet and other is dust particle. Yes, sir. Suppose if I do something by which I just apply force on this carpet and not on these dust particles, then what will happen? What do you think? Sir, if you apply force only on the carpet, then the carpet will move and dust particles will not move. They will say that since force is not applied on them, they are lazy people and they will continue to remain at rest. They will not move. Very good. So the carpet will move and dust particles will remain as it is. They will stand still. What will happen is when they will stand still, what do you think will happen? Oh my god, then those particles will fall down just like that coin has fallen down in that glass. Very good. That is how this carpet is cleaned. What you will do is you will beat this carpet through this stick. This stick will turn this carpet into motion. Will turn this carpet into a moving carpet. The carpet will move, but these dust particles, no force is applied on them because they are very small. You cannot apply force on that dust particle. So what will happen is those dust particles will stand still in the air and suddenly they will fall down. And in this way, you can clean the carpet. Wow, that's a very good explanation. Now there is another puzzle for you. This is a tree on which fruits are hanging. You want to pluck those fruits. What will you do? Sir, I will climb the tree and pluck those fruits. Again, you are thinking like a common man. You should think like Newton. Did he apply that theory here as well? Yes. Okay, let me pause the video and think again. Very good. Sir, what I have to do is I have to do something by which tree should move and these fruits should not move so that so that those fruits remain hanging in the air. Very good, very good. Now I will explain what you can do. What you can do is you can move the tree. What you have to do is you have to shake the tree vigorously. That means you hold the tree and move it very vigorously so that the tree's stem and leaves should all move, but those fruits, the force is not directly applied to them. So what will happen is they will keep hanging in the air and suddenly fall down. And in this way you can use the Newton's first law of motion to directly get those fruits in your hand. Thanks guys for listening this video. If you like it, just just share this video with your friends. We just want more and more people like you to enjoy this learning, to enjoy studies and not be fearful of the tuition and the school. And just in case you are seeing this video for the first time and you want more such videos, you can send us a SMS on this number. That is 918800789246 with details, your class and your email ID. Thank you.